Thank you so much. I'm so excited to be here. So, today I will be talking about Cloudflare durable objects, what, in my honest opinion, are the most underrated compute and storage option offered by Cloudflare. This talk will not really focus on how you use durable objects in code so much, but explain why you need durable objects in your developer tool belt. Toolkit, tool belt, same thing. So, our order of operations for this session. What is the Cloudflare developer platform? I was just in Stockholm giving a pretty much very similar talk there, and people do not know the developer platform. I'm based in San Francisco. Drop in the chat to where you're coming from, because people in San Francisco tend to know the developer platform. In Stockholm, not as much. So, quick overview. We'll go over what are durable objects, what problem do they solve, why should you use them, why do developers love them, and don't get me started on the name. We'll go over the name soon. We will also go over the actor programming model. Very fun. There'll be not one, but there'll be two demos, and I really wanted to live code one of them, but last time I live coded it, it did not work. But I swear the code was right because it worked that morning and the night before. And that's the thing with live demos, where you would not give it if it did not work. But then it doesn't work. Okay, I digress. How do durable objects work? We'll also touch on. And why they're better than traditional serverless approaches for stateful applications. And then we'll go over durable objects versus key value storage, which is another Cloudflare developer storage offering. Very fun. A lot happening. So I'm Lizzie. I'm a developer advocate at Cloudflare, and I play around with a lot of libraries and tools. I build a lot of hacks, demos, very fun. And I am online too much, so I know about a lot of different developer offerings. I played around with a lot of different databases, storage offerings, and I used Cloudflare before I joined, so that's kind of cool. The Cloudflare developer platform offers everything you need to build serverless applications, from global compute, storage, and some full stack services like image optimization and video streaming, and network infrastructure that scales globally on demand. Cloudflare covers security, which we're mainly known for, configuration, and maintaining infrastructure with APIs, so you can easily integrate with your existing tech stacks and focus on writing code. Who here has used Cloudflare Workers? Well, it is a serverless platform where you write a fetch handler that processes requests and returns responses. It offers JavaScript, TypeScript, Python support. You upload your code to Cloudflare, and they handle the deployment and execution. Unlike traditional serverless platforms, Workers uses a unique runtime and operates globally across all of Cloudflare's data centers, effectively making planet Earth the only region. When you deploy a worker, it runs from the nearest Cloudflare data center to the user. So this global distribution around the globe ensures low latency. Very important. Developers host and build a lot of serverless apps and tools on Cloudflare Workers. However, it is stateless. In the handler, there's nowhere to add to store global state. You could store things in global scope. Usually that's not what you want, because workers run in so many places all around the world, and each of these locations has hundreds of servers. Cool Workers app that I am itching to get back to once this time is over, but I stayed up late working on. If you're a fan of March Madness, basketball, kind of like data visualization of college basketball data for men and women, and some AI analysis. Been playing around with a lot of AI. And Cloudflare also hosts open source models, so you can run inference on model. Beta models are free. So I use Llama 3.2, Llama 3.3, and I'm like, here's this data, analyze it, give me some feedback, give me some analysis. And I also use a lot of Cloudflare storage options. There's D1, which lets you build natively serverless relational. It's a serverless relational SQL database with point-in-time recovery. Durable objects, which we will be talking a lot about today, helps you maintain strong consistency of state across multiple clients, events, and connections. Hyperdrive is a service that accelerates queries you make to existing databases and get faster to access your data from all over the globe. KB, key value, lets you store, modify, and query non-dynamic key value data. And R2 is a zero egress-free object storage. Yeah, a lot of options. Sometimes I misuse these because I use one when I could probably use another, but I'm like, it's storage. Oh, probably shouldn't have said that on a recording. But I'm like, sometimes I forget which one to use because there's so many. And like some are faster, some are like more dynamic. Anyways, moving on. Yeah, durable objects, main point of this talk. Now, we all know that there are two hard problems in computer science. You have cache invalidation, naming things, and off-by-one errors. A lot of people on Twitter, online, think that durable objects is not the best name. Yeah, some like John would say it's a really bad name for something that is actually really cool. And durable objects is a lot of things. So it's kind of like complicated to explain. Like, oh, it's a computer, it's a server, it does a lot. A lot of people have thoughts on them. They need a rebrand. We're working on that. Actually, we're not. I don't know why I just did that. It just seemed like the right thing to say offhand. Could be renamed, something like worker container, a remote machine you can assign work to. However, the name sticks and so does developer love. Valentine's Day was last week, but still. So, the problem with state. It's kind of like painful to manage it. You could just throw everything into your database, but then every time you need data, you have to ask politely, wait for the database to respond. It could be slow or overloaded, and then the app is just sitting there, awkwardly staring into the void. You have some latency issues, like imagine you have a multiplayer game where every move has to go to a central database before anyone sees it. By the time your move registers, your character is already dead. Or maybe they're stuck in some like quantum superposition of moving and not moving. And if you've ever dealt with multiple servers trying to update the same data at the same time, you know the horror. Two people edit the same document, and suddenly half the text disappears. The other half is who knows where. And you're apologizing to the database. It should be apologizing to me. Chaos, not chaos. Here, we have chaos and inefficiency. Users and requests are being scattered across multiple servers and databases, leading to disconnects and complex architectures, which is typical of a traditional serverless system, though they struggle with real-time, long-running, or multiplayer apps due to their request response model and lack of proper WebSocket support. So, solution, a more streamlined approach using durable objects. Each chat room, for example, could be managed by a single durable object, with users connecting to it via WebSocket. This eliminates disconnects and simplifies the architecture, making it ideal for real-time multiplayer chat systems and also games. The durable objects provide strong consistency, low latency, and seamless state management, solving the limitations of serverless systems and avoiding database bottlenecks. So, our durable objects. Each durable object is a globally consistent, distributed instance that can maintain in-memory state across requests and coordinate across multiple instances. This is particularly powerful for building stateful applications at the edge, which makes sense. It's built atop Cloudflare Workers, which is edge compute. Each durable object instance has its own durable storage, like a key value stored, persisted across requests in memory state, and it executes in a single-threaded fashion. Also, you get to decide the location. So you could be like Bay Area, or you could be like, my users are on the East Coast, fit somewhere there. Very cool. Objects maintain their state in memory for fast access, like computer RAM, while also persisting to disk. And multiple requests to the same object are serialized, preventing race conditions. Each durable object can handle complex business logic and state mutation. Workers can send messages to a durable object by its unique name, ensuring all requests to that name are routed to the same instance. There's support for WebSocket connections and long-lived sessions. You can coordinate between multiple clients and requests. And of course, there's automatic distribution across Cloudflare's global network, and objects are created on demand where needed or scale. So, Actor Programming Model is a framework for concurrent and distributed computing where actors are the basic units of computation. Each actor is an independent entity operating asynchronously, enabling with others, or enabling them to run in parallel across multiple machines. With its own state and behavior, communicating with others by creating other actors. And it can also send and receive messages and decide what to do with the next one in response to incoming messages. Actors process messages one at a time, ensuring sequential execution and avoiding shared state concurrency issues like race conditions. Each actor, let's say, has its own private state and can decide how to process the next message based on that state. This actor holds a balance. $5. Why not? It gets message and updates state. Now for the next message, the actor has this new state. Now it's not 5, now it's 7. Actors don't share memory and they interact only through immutable messages. This is widely used in systems needing concurrency, distribution, and real-time communication, like Erlang, and durable objects for stateful, globally distributed workflows. Okay. So each durable object runs in exactly one location in one single thread at a time. So they're single-threaded. Each object has its own private on-disk storage, which is a very different situation from a typical database where many clients may be accessing the same data. In durable objects, any particular piece of data belongs to exactly one thread at a time. And I could tell you, I'm going to show you, we're going to move on to a demo. And you can scan this QR code. And you should, because we're going to have some fun collectively. It's also this URL, drawtest.lizziepica.workers.dev. And let's say, refresh. Look, that's still there. Someone is drawing. That is not me. But we can also open it in a new tab and see it. So I will also write something. I wrote hi mom before. I can also erase, smiley face. Yeah. You can also clear all. We all have that power. You can also erase. Whoops, I didn't want to erase all of that. That was a big eraser. Yeah. So while we're playing around with that, let's look at the code. And I'm going to be completely honest. Who here has been using AI to write code? I use Claude to write most of this. Claude's not Claude, Cursor. I guess Cursor uses Claude. And it's been getting better. Like for a while, I had to tell it more, it took more time to get what I wanted. Okay. So We have a Cloudflare worker, which is index.ts, that has our fetch request. And there is a path name draw that we're going to hit via this file. We get the drawing room durable object and send request to the durable object to handle all drawing related logic. And we display HTML, which is a static file. This one. Yeah. That spacing could be better. Anyways. Okay. So drawing room logic. We have our sessions array, strokes, session for WebSocket, strokes for like drawing, and we keep track of state with durable object state. Block concurrency while ensures that initialization happens immediately and no requests are delivered until initialization completes. Upon initialization, we load the existing strokes from storage. We retrieve those. If strokes exist, we only get the most recent 1,000. Otherwise, it got kind of confused. It was kind of like slowed down. We limit the stored strokes to prevent unbounded growth. Do handle WebSocket upgrade. WebSocket pair is provided by Cloudflare that helps us work with WebSockets. Yeah. We accept the WebSocket connection, add that session to our array, and send the current state to the new client with the strokes. Handle messages from this WebSocket. We save the stroke with different coordinate data. And the color, the size, also a timestamp. Save to the durable storage with the specific key. There's our key. And that put. I think it's very intuitive. We save with a .put call. And if we clear, then clear of the strokes array, and persistent strokes is also now an empty array. And then this is broadcasted to all the connected clients, everyone who joined, everyone who views that web page. And we remove the session upon close, and then send that message to all connected clients. Yeah. That is not bad. Like, I feel like when I was doing college hackathons, I had a team once that wanted to build something similar, like Google Docs collaborative. And we had to, like, it took a lot more code than that. Yeah. Okay. Yes. And then another app. This is the one that I wanted to do live, but we all know sometimes doing it live does not work. But here's the coffee counter. Coffee poll. What do you prefer? I personally prefer latte. Yeah, maintain state. Latte winners are winning. And I will drop that in the chat. I drop it in the chat now. 8 minutes. Just kidding. I'm going to move faster. Okay. And I'll share this code after, but this code is on GitHub and you can view it at your own peril on your own. Okay. Back to slides. 8 minutes. I think 8 minutes is fine, but okay. So the durable object solution, how durable objects work. Every durable object is tied to a unique key, or it defines its scope and identity. This key determines the specific durable object instance that processes requests, as well as the persistent state storage associated with the instance. A use case, like let's say in a multiplayer game, each game room could be represented by a unique key, such as game room 123, and requests targeting this key are always routed to the same durable object instance, maintaining a consistent view of the state, like player position, player scores, and Cloudflare ensures that requests are routed to the nearest durable object instance, reducing latency. When users from different regions access the same instance, Cloudflare intelligently routes traffic without duplicating state. And each chat session is a durable object. You can just forget about it, let it go. Durable objects in Cloudflare can be thought of as virtual cloud-based computers that persist state across requests. They function similarly to early gen servers, maintaining long-lived processes that handle input, perform computations, and return output while keeping some in memory and persistent state. The computers as a model. A computer, physical or virtual, processes input, performs operations, and returns output. Durable objects follow this model, but they exist in the cloud. Stateful sessions. Instead of treating each request in isolation, durable objects allow for stateful interaction, making them ideal for scenarios like user sessions, like shopping carts, profiles, or collaborative applications like multiplayer document editing. They offer WebSocket support. Unlike traditional serverless functions, durable objects support long-lived WebSocket connections, enabling real-time updates in apps like collaborative editors. Woo! You can coordinate multiple sessions. And for persistence and scalability, while they go to sleep when idle to conserve resources, they persist state via stored and can be distributed across means. You can also build game engines and run AI models from a durable object. The sky is the limit. Why they're better than traditional serverless approaches for stateful apps. Traditional serverless requires more steps. I like how durable objects, you get consistency without complexity. A key advantage over traditional serverless approaches is that they provide a much simpler programming model for building stateful apps instead of managing complex distributed systems with external databases, message queues, cache layers. Developers can write code that looks and feels like regular object-oriented programming while getting the benefit of distributed computing. For example, implementing a distributed counter traditionally might require a database for persistence, cache layer for performance, block management for consistency, queue systems for coordination. My counter code did not have any of that. There's no need to connect to or maintain external databases. State is maintained close to where it's needed, and there's automatic coordination between instances. You only pay for actual compute and storage used. No need to provision or maintain database instances. And there's automatic scaling without over-provisioning. And reduced bandwidth costs due to edge locality. We love that. Objects can be created in Cloudflare's network. When to use durable objects, real-time applications, we have chat systems, collaborative editing, live dashboards, which I'm excited for, with like the basketball data. I think it'd be cool to look at like Twitter sentiment, like what are people tweeting about in real time. Not a fan of the Twitter API now, but I guess like you can also scrape the web. So like you can still get the data. I think data is cool. So like real time data, especially like during a basketball game. You can also like visualize that. Okay. You can also use durable objects for session management, shopping cart, auth states, user sessions, coordination like event ordering, queue management. Versatile and simple. IoT device synchronization, durable objects versus KB key value. Now, this slide is mainly for me since I often use one of these products when I should use the others. Durable objects offer low latency, but higher latency than KB because they provide strong consistency and stateful computation. Ideal for stateful, real-time workloads where consistency and coordination are critical, like user sessions, real-time collaboration, or multiplayer games. Cloudflare KB, ultra low, insanely low latency, like sub-millisecond read, because they're globally distributed eventually consistent key value store. This is ideal for read-heavy, stateless workloads where strong consistency is not required, like caching, configuration data. KB is low latency, low consistency. Durable objects are high latency, high consistency, cast in real time. Yeah. So what is next? What comes next? Durable objects enable stateful edge computing by allowing developers to maintain state, user sessions, real-time data directly on Cloudflare's global edge network, reducing latency, eliminating the need for centralized servers. You can run SQLite in durable objects, which provides a familiar, lightweight database solution with the added benefit of global distribution and stateful persistence. It simplifies building apps that require low latency, durable data storage without the complexity of managing servers or infrastructure. Durable objects enhance scalability with automatic scaling. Instances scale horizontally across Cloudflare's edge network. Latency state is kept close to users, reducing round trips to centralized databases. And each object is independent, improving fault tolerance. Because you can interact with durable objects via HTTP requests, WebSockets, or plain functions, they'll keep running, maintaining their state and performing tasks. And this makes them perfect for AI agents that need to perform long-running jobs like researching data, sending email, or scheduling reminders without requiring complex infrastructure like Kubernetes or virtual machines. And this is what I'm most excited for about durable objects and the Cloudflare platform. I think AI agents they've been having a moment. I think this is the year of AI agents, and we're hosting AI agent hackathon. There's AI agent meetups. It's like, I feel like, it's big. I'm excited. And I can't wait to see what people build, what AI agents people build with durable objects. And just in general, there's some good ones. Okay. Quick overview, don't tempt fate, maintain state. Whenever a request comes in, Cloudflare either spins up a new instance of a durable object or routes traffic to an existing one. Each object processes one request at a time, preventing race conditions. Each instance of a durable object is tied to a specific key, ensuring that all requests for that key go to the same instance. It provides super fast temporary storage that stays in memory as long as the object is active. This is faster than disk, perfect for active game states, user sessions, or real-time counters, but it is volatile and goes away if the object is evicted from memory, and only one piece of code runs at a time in each durable object, making it much easier to reason about state changes, and you don't have to worry about multiple requests changing data simultaneously. This is a cool app that lets you track that durable objects are made. So when you load this website, where.durableobjects.live, a worker in San Jose, I believe, created a durable object there. And when I was in Stockholm, there was one in Stockholm. Woo. Further resources, and I will be sharing these slides after the talk. So you can look at the slides and these further resources. Thank you. We're at time.
Great timing. All right. So we did have a handful of questions from the audience. So I'm going to get to those in a second. I think one of the things that you kind of brought up, which I think I remember was one of the things I struggled with when moving from Cloud to Cloudflare, some of the work that I was doing in Cloudflare, was this idea that it's different than, say, if you're going from like a typical AWS or Azure kind of model where you're in a region and you're pushing code, like workers are not sitting in a single region, workers are distributed globally. And so your thinking has to change, right? And I think that's part of where the confusion comes, because if I deploy a Lambda on AWS, I might say oh, I deployed that Lambda to US East 1. It lives in the US East 1 always. But the workers are distributed, which I think is where some of this idea of durable objects comes in, right? Because you have workers basically everywhere in the globe, but somehow the KV, which is, as you mentioned, is like distributed across the globe, right? So eventually consistent, right? 'Cause, whereas like this, it sounds like it sits in a single place in the world, right? Like it is sitting essentially like a region, right? Am I understanding that correctly?
I think that's a good explanation of it.
Okay. Yeah. 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 So I mean, I want to get to the questions. So Estelle asks, is this part of an official spec? Is there like a durable objects API that is in the browser, or is this just a Cloudflare thing?
You can think of it like an API. It's like a Cloudflare product that you can use
Okay.
for storage in your web applications.
So it's just, this is not like some kind of like public API. It's just, it is a Cloudflare only, like durable objects are a Cloudflare thing. Okay. 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 Um, So what are the cases, Alexander asked, what are the cases that you would not recommend using a durable object?
This is interesting because I use it when I really like shouldn't. Um, I have one app where I use it for like a leaderboard, and I don't think that a leaderboard is necessary um,
Right.
for durable objects. But I just like I think that's like good code, or like it was kind of intuitive to use.
Okay. Now, I guess my question is, if I recall correctly, durable, like the KV up to a certain point is free. But durable objects was always like had a cost associated with them. Am I correct? Okay. This is
That
one of
is
the, I guess one of the
good.
factors to consider, right? Yeah. Okay.
Yeah. Payment, I think
Um,
like high high throughput, low latency global RAID, like um if you need like really fast distributed read, like a CDN, like caching layer, maybe durable objects aren't ideal for that because each object lives in a single location. Global read latency could be high.
right. So
Or maybe
you
like,
sacrifice a little bit of performance for the sake of consistency. This is basically the idea.
yeah,
Okay.
or like maybe
Makes
like extremely large data set.
okay.
Those
That
would
makes
be that
sense.
would be slower. And like the leaderboard that I use durable objects for, like I could use it, but I probably shouldn't have used D1, the Siegle database.
Yeah, and that I guess, because one of the things that I found tough is like to kind of wrap my head around is Cloudflare, which is one of the great things, but also one of the tough things when you're trying to choose is like you have D1, you have KV, you have durable objects. I think there's even a couple other options in there. Like, how do you decide in any particular case, like, okay, this is the right solution for that particular use case?
I'm on a durable object kick. So like for the leaderboard, I was like, I'm just gonna use it. I was using it already for state for a game. I was like, I'll just add another one because like you can make them on demand. Uh, but sometimes I use one and then I'm like, I should probably switch to D1 or something for like speed or like handling larger files or more data. Yeah. Like I like
Mm.
durable objects.
Yeah.
I think it's kind of intuitive, but I use them often when I shouldn't.
So I mean, it sounds like shouldn't be is more like a preference as opposed to, like, it's not a hard and fast rule. Like, I shouldn't have used it, right? Like, I mean,
Yeah. It's
yeah.
like there's better
If it works.
options, but like I'm like it works. Yeah.
So Nick asks, it's still not clear to me how it's durable everywhere, no matter where you are on the planet. It's always synced with latest changes. I get that Cloudflare's network is all over the world, but still not completely clear to me. So that, I think that gets at that idea that actually the durable object exists in a single location. All right, am I correct?
And
Okay.
you can spin different ones up in different locations. And you can say like put it in a certain area. I think, but this is where like the naming comes in. That could be a better name. Durable I think here it refers more to consistency and persistence as
Mhm.
opposed to high availability across multiple regions.
So would you, in the case of like, say, let's say we're talking about a game, like, and you have users around the globe, would you actually try maybe set up multiple durable objects for different regions, or would you have a single one sitting in a particular region? I mean, I'd assume, say, you had it sitting in the US, some latency from Asia might be an issue. So you'd recommend setting up multiples, or just one? Multiple.
I would spin up multiple.
Okay. Okay. And is there a way to like sync those multiples, or is it really just like they the state only exists in that particular instance of the durable object?
You could sync them all together. Because each durable object lives in that like one single location. You wouldn't want all people worldwide connecting to the same object. You could share via that ID or like a key.
Okay.
Yeah. I think we're three durable objects, like one per continent, one per area.
Okay. Um, and then Alexander asked, do you know any backend full stack frameworks that integrate with durable objects already?
Backhand.
Like back end, like any
There-
frameworks that are kind of our built-in integration with durable objects.
We recommend Hono, uh, which was a framework created by someone on my team. Well, he created it, then he joined the team. Durable objects is designed to work seamlessly with workers. Express, Pacify.
So yeah, I mean, essentially, it can work with anything, but there's not like does Hono have something built into the framework that allows you to kind of easily leverage durable objects, or is it kind of the same? Like, I could use an Express, but it's not necessarily like built into the framework to connect to a durable object, correct?
Yeah.
Okay. Okay.